everyone. We are from section 2, group 7. So today we're going to presenting our project report for mathematics technology 1. Okay, so firstly, my name is Nur Nafisa Natasha binti Hizam Shah.
My name is Khadija binti Lokman.
Hi, I'm Yuventira Kiramesh.
Hello, my name is Brian Dinesh Lee.
Okay, so firstly, this is our table of content. Okay, so my part is introduction. Okay, I will show you this is the background of differentiate. So differentiate is a key concept in calculus. It helps us to find how things change like speed or slope. It was developed by Newton and its use is many fields like physics and engineering. Using simple rules like the power rule, we can solve many real-world problems. Okay, so this is a background of integration. So integration is like the opposite of the differentiate. It helps us to calculate area under curve and totals like volume and energy. It has two types. Firstly is definite integral and the second one is which is a specific find of value, and indefinite integral which give general formula like integration is used everywhere from physics to geometry.
In this session, I will explain how differentiate helps us solve maximum and minimum problems, find the highest or lowest points of a function, which is useful in solving optimizing problems. For example, we can determine where a function has a turning point by setting the derivative to 0. Using the second derivative test, we can confirm whether the point is a maximum, minimum, or inflection. This technique is widely used in designing systems, calculating efficiency, and solving everyday issues, challenges like minimizing costs.
Differentiation and integration are two fundamental operations in calculus. These techniques are applied to various types of functions, including hyperbolic function, inverse trigonometric function, and inverse hyperbolic function, which has numerous applications in physics, engineering, and mathematics. So first of all is hyperbolic function. Hyperbolic function are analogs to trigonometry function but are based on exponential expressions. The primary hyperbolic function includes sin h, x, cos hx, and tan x. So those are the examples.
Now let's look at inverse hyperbolic functions. Inverse hyperbolic functions such as r sin hx, r cos hx, and r tan hx serve as the inverse of hyperbolic functions and play an important role in various scientific computations. Differentiating r sin h yields, while r cos hx differentiates to integrating functions involving expressions like or leads to inverse hyperbolic forms, including r sin hx and r cos hx, respectively. And we can see a bunch of examples of differentiation of inverse hyperbolic functions and also integration of inverse hyperbolic functions.
Okay, so now we go to 2.0, which is maximum and minimum problem. So my part is 2.1. So we're going to determine the point P on the line that is closer to the point 50. What is the least distance between P and 50? Okay, so let's solve a simple problem. This question need us to find the point closer to 50 on the line. So using the formula, we found the closest point is when the least distance is about 47.4 unit. This show how differentiate help us to solve optimist problem easily. So this is boleh bisa? Okay, so 47.4 is the final answer.
So this question asks us to minimize the surface area of cylinder container with a fixed volume of 64 in power of 3. The aim is to find the optimal dimension, radius, and height. So the volume of the cylinder is given by V equals pi r square h. We arrange to express height in terms of radius. Step 2, define the surface area and substitute h into the surface area formula, get pi r square plus 128 divided by r. For step 3, minimize the surface area and solve for the height, like Let's substitute R into the volume equation to find h. Substitute R and the final dimension are a radius and height of 217 inches.
So the third question is, build a rectangular pen with three parallel partition using 500 feet of fencing. What dimension will maximize the total area of the pen? So the first step is the total amount of facing x is given by 500 equal to 5 width plus 2 length is equal to 5x plus 2y. So that after the calculation, we wish the maximum the total area of the pen is a is equal to width length is equal to xy. However, before we differentiate the right length pen side, we will write it as a function of x only. So substitute for y getting.
Okay, now we got to differentiate this equation. We'll get the answer as shown, which is 0, and then for x, we will get 50. And then to find the minimum and maximum value, we got to make like a graph, and then we'll get the final answer, which is x equals to 50 and y equals to 125. And then the largest possible area of the pen is 6,250 feet square.
Okay, so we move to 3.0. So in this part, we're going to determine the differentiate of the following function with respect to x. So in this question A, which is fx equal to sine h 1 per x. So in this part, we find the derivative of given function using differentiate rules. By applying the correct formula, we determine how the function change at any point. Differentiate help us to analyze and such a problem quickly and accurate. Okay, so in this part A, I'm use the symbol lab software. So by using the hyperbolic function, we get the final answer, which is fx equal to minus cos h 1 per x equal to x squared.
So this equation involves differentiate the function the f of x equal hyperbolic function. So we get a d by ds of tan of ln x equals sec square of ln x multiply xn. So we we use mathematics software like Symbolic.
For the third C question, the method is we need to use chain rule and simplification. First step, we need to recognize the function. So the derivative is c power of negative 1, bracket u is 1 over z1 minus u power of 2. Step 2 is differentiate 3x as the inner function. So we need to use the chain rule. So the third step is substitute and simplify. So we will get df over dx equal 3 over z1 minus 9 x power of 2. So as you can see, we use the mathematical software such as Symbolic. So the answer we will get is f over dx 3 minus f x cos f x over x cos f x.
So this question is learned as cos power of negative 1 x, apply the product rule and simplify and get the r cos x negative x over square root y negative x squared. Okay.
The fifth question is same as well. We need to use chain rule and hyperbolic identification. The first step is recognize the function. Then the derivative is cos h power of 1 negative 1 in bracket u is 1 over sec u power of 2 minus 1. Second step is we need to apply the chain rule. So the answer we will get is df over dx equal to 1 over sec x over 5 power of 2 minus 1 times 1 over 5. So we need to expand it. We will get the answer as the symbol f. df over dx is equal to 1 over sec x power of 2 minus 25.
Okay, so part F here we're gonna differentiate the function fx equal to 1 per tan 10h. Okay, so using the chain rule and differentiate formula, we will get the result. Here we use the function of inverse hyperbolic using the same software, which is Symbol Lab. So we get the final answer, which is fx equal to minus 1 per 1 minus x. Okay, so this is the final answer.
We're going to look at 4.0, which is determine the integration of the following function with respect to x. Okay, A. Let's look at the question. First thing first, we gotta substitute. You gotta let u equals to 4x cubed. So du equals to 12 square dx. Then we gotta rewrite the integral. And then the integral of ch square bracket u is cot u. And then we'll get the answer. We also can use a mathematical software such as Symbol Lab to solve this.
So the second question, the method we're going to use is integration by parts. Step 1 is identify components for integration by parts. So we need to let u equal x and dv is equal to SEH power of 2x dx. So the formula is u dv is equal to uv minus u du. So the second is differentiate and integrate. After we get the answer, we need to apply the formula. So the formula is tan h x dx equal to in cos h x. So after we use the formula, the answer we will get is x tan h in bracket x minus in cos hx plus c. As you can see, we use the symbol f as well. We will get the same answer.
So this question involves finding the integral of 3 divided by 3 plus x squared with respect to s, apply integral substitution and simplify it. And then we get the square root of 3 times arctan of x divided by the square root of 3 plus c. Okay, so we use mathematics software Symbol, and the function is inverse trigonometric functions.
In this part, we solve the integral of negative 3 divided by the square root of 9 minus x squared. Okay, so using the rule of integration, the result is negative 3 times I sine of x divided by 3 plus a c, which is c is constant. The example show how integration can solve problem involve square root and trigonometric relationship. Okay, so using this Symbol Lab mathematics software, so we get the final answer.
Okay, now question E. We got to solve fx equals to 1 over x, the square root 1 minus ln x square. So first we got to let u equals to ln x. So du equals to 1 over x dx. The integral becomes as shown. And then the integral of 1 over square of 1 minus u square is arcsin. The bracket is question F, which is fx equals to negative 3 over x to the square root of 4 minus x squared. We use the same method as we did in question E, and then we'll get an answer which is negative 3 arcsin in the bracket x over 2 bracket plus c. As said, c is constant. You also can use the software Symbol Lab and we will get the same answer.
Okay, so here's a conclusion. So we can conclude this project is about this project help us to learn differentiate and integration. Differentiate is used to find maximum and minimum value. Integration is used to calculate area and total. Okay, so we also explore advanced function and use tool like Symbol Lab to solve problem easily. This project show us how calculus is useful in our real life.
Okay, for the last is reference that we use several references that play an important role in any academics project, providing credible sources to support calculation, theories, and explanation. So that's it for from our group. Thank you.
Thank
Thank
you.
you.